student, welcome to our fourth part of the lesson, or lesson number 4, where I am focusing on the general solution, and the topic is under trigonometry. Very ideal for those of you who are doing their grade 11 and grade 12 preparing for the final exams. This is a must watch. This is a must lesson that you need to ensure you grab hold of, because it will assist you as you prepare for your final exams. Now, if you have not subscribed to our channel, I always encourage you guys to subscribe to our channel so that you can be notified every time we post some new videos. Now, let us look at this question. It is again, determine the general solution of the following equation, and this is 5 marks. Look at the equation. It says sin x minus 30 degrees equal to cos 2x. It's 5 marks. So how do you approach this? Having done 3 different sections of the lesson, this is also another set that they can bring that is different. I'm going to approach it in 2 different ways just to show you how best you can approach this one. Alright, let us start by looking at this. When you're given now sine and cos, what you need to know is either you work on tan, where you are given the same angle. If you are given the same angle, you're going to use tan, but now we are not given the same angle, because here it's x minus 30, here is 2x, so the same angle, converting sine and cos to tan won't work. Now we have to use the cofunctions. That's the secret whenever you're given different angles. So if you've given these different angles, go through the cofunctions so that you can change cos to sine or sine to cos. So let us start by changing cos to sine. In this case, using cofunctions, I'm going to work on it like this. I've got sine x minus 30 degrees is equal to cos 2x. Now, as I said, I'm going to use cofunctions, converting this part to sine. So what I'm going to have therefore is sine x minus 30 degrees is equal to cos. Now when you're converting to cofunction, you no longer write cos, you say sine, because it's a cofunction. Now cofunction, just to make an example here, if I have cos 30 and I want to convert it to sine using cofunctions, it will be sine 90 minus 30. We can test with the calculator, you'll see what I'm talking about. So if I say cos 30, you see it's root 3 over 2. Then if I say sine bracket 90 minus 30, you're also getting root 3 over 2. Do you see what I'm talking about? Why? Because generally, if it's cos theta, it becomes sine, but it's 90 minus theta. So that's what is happening. So in this case, if I'm going to convert it also as a cofunction, now our angle is 2x. So I'm going to have here 90 minus our angle, which is 2x. That is how I'm converting to the cofunctions. Now, the aim was to get sin and sin like that. When you do that, you can drop out the sin. You don't cancel them, you just drop them, and you write then your answer as. Now, be careful how you write your answer. Take note. I will say, therefore, x minus 30 degrees, which was the angle here, is equal to that particular angle, which is 90 minus 2x. But once I do that, I will say x minus 30 degrees is equal to 90 minus 2x. I need to put the general solution in check for sine. Now, if I go back here to my cast diagram, this is the most important diagram according to my way I see it whenever it comes to trig. Remember, all students take chemistry. Now we are looking at sine, and in this case you can see that we have a positive for sine. So sine is positive in the first and in the second quadrant, and in the second quadrant the reduction rule is 180 minus theta. So the first quadrant we are dealing with, here we're dealing with the first quadrant. I'll call 1 for first quadrant. Since we are dealing with the first quadrant, we are going to say it's 90 minus 2x, which is treated as one angle, and then you say plus here k 360. Okay, where you put the condition k is an element of z. Then you need to simplify that. We're going to go to the second quadrant, but now this is the first quadrant. Let's simplify that. What you do is you take negative 2x on the other side. You have got x plus 2x is equal to, you take the 30 becomes 90 plus 30 plus k 360. Seeing that x plus 2x, we have got 3x is equal to 90 plus 30 is 120 plus k 360. Then we have to divide each and every item by 3. Even the k 360 you divide by 3. So it's very important, don't forget that, you divide by 3. So when you do that, you have got x is equal to 3 into that, it's 40. So I've got 40 degrees plus k. If you divide 3 there, it's 120. So plus k 120 degrees. That is the first general solution. Remember, this is in quadrant number 1. You don't have to show it that is in quadrant number 1, but I'm just trying to make it easier to understand for you. Now let us look at the second quadrant. I'll call this one now quadrant number 2. The general solution, remember the reduction rule is 180 minus theta. So what you're going to write, you are going to come back, we are in this stage here where we are dropping the sign. So we are going to write x minus 30 degrees is equal to, now here because we want to write the angles 90 minus 2x as I said, so we are going to say the reduction rule is 180 minus your theta here is your 90 minus 2x. So you put a bracket, you say 90 minus 2x, you see that, and then you say plus k 360, and you say k is an element of z. Now this is 180 minus your theta represented by 90 minus 2x in that particular case. So when you've done that, what is important is for you to further simplify that, which is x minus 30 is equal to here 180 degrees minus, open the negative, and the negative will make the negative 2 positive, so it's minus 90 plus 2x plus k 360. Now collect like terms. This the 2x will go to the other side becoming negative, so it's x minus 2x in this case is equal to 180 degrees minus 90 degrees. The 30 will come and add, become plus 30 degrees plus k 360 degrees. I hope you are able to see what I'm talking about. So x minus, so here it's x minus 2x is negative x is equal to, if I can quickly add this, is 180 minus 90 plus 30, it is 120. So I've got 120 degrees plus k 360 degrees. Now I have to divide by negative 1 on each and every item, negative 1, giving me my value for x now, such that x is equal to minus 120 minus k 360 degrees. So this is the second general solution, which is in quadrant number 2. So if I was maintaining my answer, let me try to use the other method where I'm actually changing the cofunction. Instead of cos, I'm going to use sine. So let me rewrite this, whereby I have Let's do it again. It was sine x minus 30 is equal to cos 2x. Alright, so that's what we're given. Just to verify again, sine x minus 30 is equal to cos 2x. That's what we have. Now let's look at it the second way in another angle. So I'm going to convert sine now as a cofunction. Remember, it's 90 minus, so I'm going to have sine. When I'm converting, I don't have to write sine now, I write cos, because it's a cofunction. So it will be cos, do that, then I've got 90 minus that angle, which is in bracket x minus 30. You see, that is when I say 90 minus that angle, because this is treated as your theta, so it's 90 minus that particular angle, which is equal to, if I can just show you this to say here, just to take it much slower for you so that you can understand what I mean. So when I'm converting to cofunction, it's 90 minus theta is equal to cos 2x. Now my theta here is that, so it will be cos 90 minus bracket, that's why I put a square, then it will be x minus 30, see that, is equal to cos 2x. Now you have to simplify inside, which is cos, so it's 90 minus x plus 30 is equal to cos 2x. We can further simplify to say cos 90 plus 30 is 120 minus x is equal to cos, it's not cos x, I mustn't lose that, it's cos 2x. There is a 2 there. So now, because I've got cos and cos, I can drop the cos so that I have, and say therefore, in this case, 120 degrees minus x is equal to 2x. Now, at this stage, actually let me use a different marker here. Look at this now, how I drop it. Therefore, 120 degrees minus x is equal to, now I'm dealing, let me see here, I think I'm missing out things here. Okay, the other one was sine, so okay, I'm fine. Yes, this is correct, I'm dealing with cos now, because previously I was dealing with sine. So now I'm going to use the general solution for sine. So this you are going to say 2x, then you're going to say plus, go back to your cos diagram, and say where is cos positive. All students take chemistry. Cos is positive in the first and in the fourth quadrant, and in the fourth quadrant, remember, is 360 minus theta. So the first quadrant, this is quadrant number 1, we are going to say 2x plus k 360. Are you seeing that? So when you do take 2x to the other side, we have got minus x minus 2x is equal to, then it's minus 120 plus k 360 degrees. So you've got minus 3x is equal to, then you have in this case minus 120 plus k 360, divide by negative 3, you divide by negative 3, you divide by negative 3. So when you do that, we have our x is equal to, when you divide there, you will have 40 degrees plus, and then when you do that, it will be, remember we're dividing by negative 3. Let me just check if again I'm doing this thing right here. So it was 90 minus x plus 90, 120 minus x, yes, so it's negative x, and here it was x minus 30. Okay, so we are still doing it right. So the question, yes, so now if I continue like that, it will be divided by, so it will be minus, not a plus. I was just querying this negative here, but it's fine. It's minus k 120. If you divide this into that, you get 120, but it's negative k 40 minus k 120 degrees. So now we're going to compare this after. Let us look at the second version of the solution. And the second version of the solution here, it's in quadrant number 3, which is 360 minus. So it will be 120 degrees minus x is equal to 2x. You see that? And then, actually, I mustn't write 2x. First of all, I must write the reduction rule, which is 360 degrees minus theta. And this is your theta, remember? So it's minus 2x plus k 360 degrees. You see that? When you simplify this further, now the 2x jumps this side, the 120 goes that side, so it's minus x plus 2x is equal to 360 degrees minus 120 degrees, as you can see, plus k 360 degrees. So when you do that, you've got x is equal to 360 minus 120. 360 minus 120, it gives you 240. So this is 240 degrees plus k 360 degrees. So this is the general solution. Remember though, I forgot this, k is an element of z. They will penalize your marks if you forget that. So this is the second general solution. So we have got two answers. The other one is 40 minus k 120. The other one is 240 plus k 360. If we compare with the other sign, it was here 40 plus k 120, and then we've got minus 120 minus k 360. Now these answers, in as much as they look different, they are not different in a way. They are the just because of time, I would have proved to you to say, for example, here if I say let k equal to 1, so if k is equal to 1, you are going to have 40 plus 120, which is equal to 160. So we say here, we just trying to test when k is equal to 1, which is in this case, it will be angle is 160. You go to the original with your 160, go to the original where in x you put 160 and you put 160 and see whether it balances. So if I do that, I will say sin bracket 160 minus 30. I get the answer is 0.7666. I do the other side. Remember this answer. Then I'll do the other side, which is cos 0.766. So cos 2 times 160. See that? Which is 0.76666. You see the answer in this case is balancing. Now, having done that, let us try another one, the general solution. One of the general solution is here, where if we put a 1 here, where there is k, if we put a 1 here, so it will be with the calculator minus 120. So it's negative 120 minus 1 times 360, where k is equal to 1. So the answer is minus 480. So if we come here and say x is equal to minus 480, here minus 480, so minus 480, let me use a different marker, minus 480 and negative 480. Now let's do that and see where the balancing of the left and right. So sine minus 480 minus 30, what it gives us? It gives us a negative half. So let us use it this side also. Cos 2 times negative 480. See whether I'm getting a negative half. you see we are also getting a negative half, meaning our first pair of the general solution is correct. Let us try now with the one where we used the cofunction of sine. The first one is here, whereby if we say k is equal to 1 here, it will be 40 minus 120, and 40 minus 120, if you say 40 minus 120, you see I'm getting negative 80. So if we come here and say minus 80 on this, minus 80 here, so say minus 80 and minus 80, we test it again to see whether the left will balance with the right. If k is equal to 1 balances, it will balance for every value of k. Remember, k is an element of real numbers. So you've got sine minus 80 minus 30 is giving negative 0.9396. Remember that one? Negative 0.9396. We try this side. Cos 2 times negative 80 and see what it gives us. It's negative 0.9396. You see that it's still giving us the same answer. Now let us go to the last one of it. So this one is correct. Let us go to the last one of it, which is 240 plus k360 when k is 1 here. So you'll have 240 plus 360. If we add that, 240 plus 360, it gives us 600. So we are going to use k is equal to 600 in the original here. So you have got x is 600, not k, x is 600, and see if it balances. And you have got sine 600 minus 30 equal to, I'm getting a negative half. We try here again, cos 2 times 600, I'm getting a negative half. So you can see that they appear as if they are different, these general solutions, but in actual fact they are the same. So the way they can be presented looks a little bit different, but you will see that actually they give the same answer altogether. So this is what I wanted to show you here, to say whenever you're going with it, whenever you're solving the general solution, two solutions are possible, depends how you choose, but it will always lead to the same answer. Now whenever they are marking it, they will also mark your solution. It doesn't matter whether you approach it from cos perspective or sine cofunction perspective, but your answer will be the same. Guys, I hope this was of benefit to you. There is another lesson that is still outstanding, where I will continue again showing you the general solution. Now this, I encourage you to go through all the other lessons, to revisit them again and again until this is ingrained in you, so that at any moment you are able to bring solutions no matter which question they bring in your final exams. Remember to subscribe. See you again in the next lesson. Thank you.